Hello friends, welcome to today's episode of Problem of the Day series from Leetcode. Today we are going to solve problem number 2336, smallest number in infinite set. So let's get started. We have a set that contains all positive integers 1, 2, 3, 4, 5, 5 dot dot, and how long? We don't know. So if you look at the constraint, we can see that numbers are actually 1000. Right, so the maximum number I can have is 1000. That means that number set is from 1 to 1000, and we have to implement the smallest infinite set class, where the pop smallest removes the smallest number in the set, and adding back is going to add the number back to the set. So let's go through the example and try to understand what actually does it mean. So initially we have a set that contains all the numbers 1, 2, 3, 4 dot 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 999 and 1000. So when we call pop smallest, so we are going to take 1 out from the set. Then we call again pop smallest, the 2 goes out. When we add back, so suppose that now we are adding back 2 back again, so 2 comes back here. The interesting part here is that if I add 1 back here and then I call pop smallest, the smallest number in the set is actually 1. So we have to maintain the smallest number in the whole set. So there are two approaches we can take, and we can optimize different functionality we can have. So in this case, suppose that we can create an array of 1000 elements, right? And then it's a boolean, so true or false. So true means that this number is already present in the set, and false means this number is not present in the set. So with that, if I have to add a number back to the set, I have to just say my array of number is equal to true. So that means that I am optimizing add back in O1 time frame. But if I have to pop the smallest, I have to start from my array from 1 and keep on moving until I found out a value with a number where array of num is equal to true, and then return that. Then the time complexity for pop smallest is going to be On. Right, so this is one way of implementation. The second way of implementing is that we optimize a pop smallest. How you can find out the smallest number in constant time frame is by using the heap. So we can create a min heap, and we initialize the heap with all the number from 1, 2, 3 dot 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 1000. And whenever the pop smallest comes called, we just take the number from the heap and return that. So with that, pop smallest has a complexity of O1. But when we have to add back the number here, so when you're adding back the number to the heap, that means that you have to do the time complexity for adding a number here will be O of log n. Right. The interesting part which I found is that since the heap elements is allowed to have duplicate numbers, right? So we also need a way to check whether we should add this element to the heap or not. Because if the number 2 is already present in the heap and you add it again, so there will be 2 instances of 2. And when you pop this, you will getting twice, which is not what we really want. We want this number to be popped only once. So we would need a way to track the presence of each number. So the easiest way is using the Boolean array, just like in the previous approach. So let's code it. So we will create a Boolean array, and let's name it as presence is equal to null, and then in its constructor will say presence, initialize it of size 1001, and by default every element is present, so we'll initialize it with true. And when we have to add back the number, we will just say presence of this number is equal to true. And when we have to pop, so we'll start from number 1 because that is what the constraint is. I is to be less than or equal to 1000, or actually to be more precise, let's do it presence dot length plus I, and if the number is present, so we will change it to false, and you return it I. In error condition, just return -1, right? And then you run it and then submit it. Okay, it beats 52%. Now let's code it in using heap. So we are going to create a priority queue. Basically it's a min heap, right? And then actually we will do it in constructor. And fill the priority queue with the numbers for integer I is equal to 1, I is less than or equal to 1000 plus I, priority queue dot enqueue I, right? Now once we have to pop the smallest, we have to just take the number out from the heap. Num is equal to priority queue dot dequeue. We also need to update the presence of number is equal to false, and return the number. And when you are adding back, we will just check if the number is present, right? So that means that if the number is not present, then we will add the number to the presence array, and then we will just add it to priority queue. Right. Okay, so in C# we need two parameters here. It's a priority of the element actually, right? And let's just run it, submit it. All right, sounds good, it works fine. That's it for today. Thanks for watching. See you tomorrow.